All right, let's look at this. We want to graph the population of a quickly growing town as an exponential function. The town started with a population of 5,000 and tripled every decade. Okay, so let's remember the general form of our exponential functions, right? We've got f of x equals a times b to the x power, right? Where a is the initial value and b is the ratio or the common ratio of the function or of the relationship, right? We can of course also write this as y equals a times b to the x power. And let's also remember the flexibility of our notation, right? Since this is since the value of this function is the population of the town, right? And the input is decades, right? We know it triples every decade, so the input is going to be the decade and the output is going to be the population of the town after that decade, right? We could, if we wanted to, graph this as, let's say, P of D equals A times B to the D power, right? Where we have, where we call our function P for population, and we call our independent variable D for decade. And you should see that these two guys are of the exact same form, right? We're just using a little bit, just using different letters to represent the variables. We can graph this, we can use whatever kind of notation we want, right? Okay, so how do we actually get around to writing out this formula? Okay, so we need to know A, right? We definitely need to know A, which is the initial value, and we definitely need to know B, which is the common ratio, right? Now, if we look through this sentence here, we're not outright explicitly told what the initial value is, nor are we outright explicitly told what the common ratio is. We are given enough information to figure it out, but we sort of need to interpret that information first, right? Well, what are we told? We're told that the town started with a population of 5,000. Okay, well, what that means is the initial value of this exponential function is 5,000, right? Does it make sense to everyone that if we're trying to model the population of a town, and if we say it starts at 5,000, that means the initial value of our function is 5,000, right? And if we're told that the population of a town triples every decade, it triples, increases by a factor of 3, right? That means the common ratio is positive 3, because after each decade, we would be multiplying the population by 3, right? So the common ratio, or the ratio in this case, is positive 3, right? All right, so now we have everything we need to construct our formula for this function, right? We know that y is equal to positive 5,000 times positive 3 to the x power, right? We also know that there's a y-intercept, right? Where would the y-intercept? Where would the y-intercept be at on this graph? Well, it's always at the point 0 comma a, right? So in this case, it would be 0 comma 5,000, right? Just a good thing to know. The y-intercept, of course, always occurs when x is equal to 0, right? And it should make sense that the initial value of an exponential relationship would occur when x equals 0, right? Okay, how about this? A TV show is not very successful. Only 7,500 people watch it each week. Then, the network decides to start a new advertising campaign. This causes the audience to increase by a factor of 1.5 every week. Write this function in the form f of n equals a times b to the nth power. Also, how many people are watching after 5 weeks? Okay, so let's think about it. Clearly, this describes a function, right? What would the input of this function be? The input would be the number of weeks after the advertising campaign started, right? And what would the output be? The output would be the number of people watching that show that week, that number of weeks after the campaign started, right? So if we want to write this as an exponential function, what should a be? What should our initial value be? Well, our initial value is going to be the number of people who were watching the show every week before this campaign started, right? And we're told that that was only 7,500, right? We were told before this advertising campaign started, only 7,500 people were watching each week. So our initial value is going to be 7,500. That's also going to be the y-intercept, right? Because before the campaign started, that's going to be n equals 0, right? That's going to have an input of 0 because it will be 0 weeks after the advertising campaign started. So we'll have a point 0, comma 7,500, which is the y-intercept, right? And okay, what's b? What's the ratio? What's the ratio of this function? Well, what's the factor by which this audience is changing, right? We see here that this advertising campaign causes the audience to increase by a factor of 1.5 every week. So to find out what the audience would be after the first week, we take our initial value and multiply it by 1.5. To find what the audience will be in the second week, we take the audience of week 1 and multiply again by 1.5. And so for every week that this advertising campaign runs, to find how many people are going to be watching next week, we take the number of people watching that week and multiply by 1.5, right? So B in this case is 1.5, right? Okay, so we can now write this in f of n equals a times b to the n form, right? Where f of n equals 7,500, right, times positive 1.5 to the nth power. And there we go, there's our function. Now we have a question to answer, right? How many people are watching after 5 weeks, right? How many people are watching after 5 weeks of this advertising campaign, right? Well, let me block off some space here to do some work in. That means how many people are watching when n equals 5, right? So that means we're going to evaluate this function we have for n equals 5. So that means we're going to evaluate f of 5, right, equals 7,500 times 1.5 to the n power. My bad, not 1.5 to the n power, but rather 1.5 to the 5th power, right? Because we're evaluating for n equals 5. Okay, that's going to be equal to 7,500 times what is 1.5 to the 5th power? Best to use a calculator for that. And we're going to call it, let's round it to 7.6. Okay, let's round that to 7.6. So after 5 weeks of the advertising campaign, our audience has grown by a total factor of 7.6. 7.6 times more people are watching after the 5th week than were watching since this advertising campaign began. And to get our final answer, we are going to evaluate 7,500 times 7.6, and we're going to get 57,000. Still not a great audience for a television show, but it's certainly increasing, right?